Hey guys, welcome back to my channel, and today we're going to be proving the partial derivatives of this function with the limit definition. So first we're going to do it with respect to x. So just to remind you, the limit definition with respect to x will be as, delta x approaches 0, f of x plus delta x comma y minus f of x comma y over delta x. So in this case, you would just substitute x plus delta x wherever you have x. And as you can see, we get something like this. Obviously, we want to know that there's a limit here. And what we're going to do is just make the numerator, make the two fractions have the same denominator. So it just means we have to cross multiply. So that's what we're doing. Then we get x plus delta x plus y times x plus y over delta x. And again, this is assuming we're taking the limit of this. And this x plus y minus x plus y actually cancels out. And what we're left with is a negative delta x. But because we're dividing a fraction by a fraction, we're basically multiplying by the reciprocal of delta x, and hence it's basically just in the denominator. And we can actually cancel it out, so we're left with a negative 1. So delta x approaches 0 of negative 1, x plus delta x plus y times x plus y. And if we just substitute delta x for 0, we get negative 1 over x plus y squared. And if you try to do it without the limit definition, you'll see that you get the same answer. So now we're going to do it with respect to y. So again, it's the same exact idea, except it's as delta y approaches 0. So it will just be limit delta y approaches 0, 1 over x plus y plus delta y minus 1 over x plus y over delta y. And again, we want to make the denominators the same. So we get x plus y minus x plus y plus delta y over our denominator. And again, we can just move the delta y to the denominator too, because we're dividing fractions. And after we cancel, just like before, we get the exact same thing. So limit delta y approaches 0, negative 1 over x plus y plus delta y. So we substitute delta y for 0, and we get the same partial derivative. So yeah, thanks for watching.